Fine. So let's move on from Google Colab again. So as you can see, it's prepared by actually the YoloV7, which developed this algorithm. Uh, these people actually written this. So let's continue with the codes part. So firstly, we are installing the required libraries. First, we get this repository by git clone command. After that, we install this requirements text file. I showed it in the first part of this workshop. Then after installing all of these, we have to gather data. So how can we do that? Actually, if you haven't got any gather data, you can take it from RoboFlow. So RoboFlow has a universe part that actually contains a lot of data sets. For example, you can take this hats on the workers. For example, you can use it for gaming, agriculture, and other things. There are a lot of data in here, and it's also labeled. It's a very good thing, because if it's not labeled, it takes a lot of time to label it. When we are doing some object detection projects, when we are attending to the fighting UAV competition in Technofest, we have to actually label more than 3,000 images, and it takes a lot of time. Actually, it takes days to make that, so we divide it to the people. So we are actually going to detect the cars. I find this actually that has some good images, 10,000 images. And I know this group, this is the augmentation setups, startups group. They are very popular in object detection and artificial intelligence area. So you have to download this dataset. You're clicking that. There are two options. One of them is download zip to computer. We are not using that because we are not going to make this training process in our computer. We are going to use it on Google Colab. So we are pressing to the other button. So this is everything to get this data. We are copying that command and putting it to here. So by clicking that, it gathers our data on our Colab. So it takes several minutes, but I don't want to waste time. So let's talk about some other topics in object detection while it's gathering data. Okay, let me check it again, whether it is downloading. Yes, it is downloading. It's fine. The warning is not important. There are some libraries, different versions, which install, but it's not important. Okay, let's talk about that. Optimization. After your training process ends, actually this artificial intelligence models, object detection models are huge. So if you are using a limited compute capability computer, you have to optimize your model. So there are several tactics to make it. One of them is pruning. The neural network is like that. You're connecting these neurons to others, so it's making a neural network. So what are we changing in the training process? This is important. This is the theoretical part, but I want to talk about that. This connections actually means the weights. Weights means actual numbers. So you're getting that data, and after that, you're multiplying it with some coefficients. These coefficients called as weights. So after the training process, some of the weights are very strong. Like, for example, this is 1,000, this is 1,000,000, for example, like that. But some of them is near to zero. So they're not actually using in your model. So if it is near to zero, this coefficients near to zero, you're directly deleting this nearly zero connections. You're pruning your weights. By doing that, you're optimizing your actual model. But there is a disadvantage of that. If you prune it in a wrong way, you also prune the correct actually connections. So the pruning process actually brings also it makes decrease the accuracy and precision. This is an issue of this pruning. This is a classical method. It's used in the past. There are some more important techniques used in the nowadays. One of them is TensorRT. TensorRT is an algorithm that makes this optimization. It takes actually different types of artificial intelligence models. For example, it's getting from TensorFlow, MATLAB, C++, Python, this sorry, Caffe library, and other libraries. ONNX is important thing. You can convert PyTorch and TensorFlow models to that global model that makes you able to use it in everywhere actually. So there are some algorithms working on this. By TensorRT, you're optimizing your model and gives better solutions, better results to you. So there are also different techniques, for example, object tracking. In object detection, you're looking at the image and detect the object. Fine, but it takes a lot of time. So if you detect an image, you are actually, it's not required to detect it again in the next FPS, next frame. So what are you going to do? You're going to use some object tracking algorithms because tracking is faster than the object detection. For example, if object detection works in 5 FPS, the object tracking works in 20 FPS or maybe 40 FPS. It's actually moves very actually faster, and it cannot actually release the object because it's also very strong algorithm. There are some algorithms that you can use in OpenCV. One of them is KCF tracker. This is the most popular algorithm. It's fast and it's accurate. But if you want more accuracy, for example, if you are working with smaller objects, you can use CSRT. CSRT is a better algorithm. It's slower but more accurate. I tried it. So these techniques are not using deep learning techniques. It's classical methods. So they are faster than object detection. First you detect the object, then move it to the tracker, this bounding box to the tracker, then it tracks it. It's a very easy thing. And it increases your FPS. If you have to be faster, you can use this object tracking classical methods. Also, there are some modern methods. One of them is deep sort. I use that, and I actually make a video about that. This is the video's link. This is deep sort YoloV7. This is in Turkish, actually. You can use that. Also, there are some English videos that you can use. Deep sort is also important algorithm. So our dataset has installed. So what are we going to do? We are going to install the model, actually, this YoloV7 training model. So we are putting that, we are pushing that button, and it's start to installing it. It's actually installing it. Yes, fine. So after that, we are moving on training. But before going to the training, we have to solve an important issue. So from this directory button, we can check it whether our data set is here or not. So as we can see, it's here. Okay, fine. So in here, we have to find the dataset location, this data.yaml file. What is that? So let's look at it. Actually, it's, yes, it includes the names of these objects, like this is the card's name, for example. This is the playing cards on there is some written in there are some numbers and words written in here. So the class names actually these are. So number of classes, there are 52 classes in here. And it's also points where is the training image, where is the validation image. It's required when the training process are running. So we have to take this thing here, and we have to copy its path. So when we copy it to the here, let's close it. So we are already in the YoloV7 file, so directory. So I'm actually deleting this part. So it goes there, and then it finds data.this file. Yes. After that, it's find this. It's also here, no problem. We installed it in here. So device is 0. That means the first GPU. But there is also some errors in here. We have to solve it. So let's move on this utils file. In utils file, it includes our actually model. In here, the codes are described the YoloV7. In here, we have some important issue to solve. So what is that? We have to find the loss file, loss.py. So where it is, it's not here, not here. In data icon, no. In configuration, no. I cannot find it actually, this loss thing in here. Okay, let's move it. It's going to give error, and we can find this. If it is not, there is no problem. So we are started our training. So it finds the things in here. After that, it's actually makes this convolutional neural networks thing. After that, as you can see, it's written epoch. Epoch means step. So how much step you are going to train your image? It's default by 55. Yes, it gives runtime error. Why did it gives error? Because it's actually works in both CPU and GPU. So we have to select the CPU one. Sorry, the GPU one to make it better. So where is it? YoloV7 utils loss pi. We have to find in YoloV7 utils, and not here. Okay. And after that, we have to find those files. Oh, okay. Actually, the utils are not opened. Sorry about that. So we are opening it. As you can see, it's I know it's here. Okay. So the error is in here. So we have to solve this issue. I noted that. So in here, I also noted to go in here, and yes, there's some important suggestions in here. We have to take that, and we have to move it to the 685 line of our loss pi program. Okay. So that makes the problem. Actually, we have to delete it, and we have to move it here. So it's only use the CUDA, not other CPU or GPU. Okay. So we have to save it. Is it saved? Yes. Okay, fine. So can close it. Then we can run our program again. So it starts training. Okay, as you can see, it's CUDA Testa T4. This is one of the most powerful GPUs in the NVIDIA store. It's more powerful than the RTX and GTX series. So we are waiting for it starts the training. It has now 442 images in the training. So it starts. As you can see, it's actually moving on the image, and it starts to actually learning. It's looking at the image and start learning. It's moving it's to the neural networks, and it's actually start training. The training actually is a very long process. In here, for example, for one epoch, you have to wait for 3 minutes. If it is 50 epochs, it means you have to wait for 150 minutes. And many actually data scientists are waiting for days to get actually very precise results. So I'm not going to wait it because it takes the whole night. So now we have to actually train like that. I have to talk about the important thing. As I said, for example, this is started and I go to sleep. So after Google Colab understands I'm not pushing to the mouse or touching to the keyboard, it's automatically log out. So we have to solve this problem to sleep well. So how can we solve that? I also noted that. So let's find it from here. Where is it? Okay, I've forgotten to add it to here. So let's move on to the problem, YoloV7 logout problem. Not YoloV7, sorry, collab logout problem. They also solve this issue in here, timeout problem. Yes, so what are we going to do? This is a code in here. We are adding it to the or console, the Google Chrome's console. So what are we doing? We are clicking on Control, then we are clicking on Shift, and then I. But it's I in English keyboards. In Turkey, we are using Turkish keyboards, so it's actually means the letter O. So if we push it this letters, so as you can see, it's open this command prompt. So what are we going to do? We take this and we put this code, this one, to here, and press enter. So it's automatically clicks on mouse. So that means you have no issue for the session and problem, timeout problem. This solves this problem. So by using that trick, you can solve this issue. I also mentioned these in where in actually custom training parts. I guess this is this link. So by clicking, so it's you can solve this problem here. So you can learn it from here. You can copy it from here. Okay, fine. So this is all about the object detection. After this detection ends, you can download the epoch which is best for your application. You can see the precision in here. If it is finished the first epoch, no, it isn't finished yet. It's now in 58%. Okay. So after that training process, you can get the weights from this Google Colab screen. After that, you can use it on your computer, or you can save it to use in another computer. This is all about the object detection. Do you have any question? I think there is no question in here. So, fine. Thanks for attending this workshop. We will prepare more workshops in IEEE. So, see you in next workshops. Have a nice day.
Have a nice day. See you.